Hi, I'm Jason Owodyang from Code for South Africa. I'm going to show you how to use OpenRefine and pivot tables to get meaning out of messy data. I'm going to assume that you have OpenRefine and a spreadsheet program and know how to get data into these. If you don't know how to use OpenRefine, check out the introduction video on openrefine.org. We recently completed a project with a South African non-profit called Black Sash. Making All Voices Count project had people out in the field monitoring clinics and social welfare pay points, and they were getting a lot of data in that they needed to present in some meaningful way. Instead of just making them a website, we did something a little different. Hannah Williams, a data visualization designer, made them posters that they could take back to the communities and have a conversation around the data. So Black Sash's data had two big issues. The first was that it was dirty, which is pretty normal for raw data, especially when it's collected by lots of people out in the field. You get spelling mistakes or people just enter the wrong data. The second problem is that the survey software they used gave us data that was very difficult to interpret in a spreadsheet. We wanted to use spreadsheets and pivot tables to understand the data, and the format it was in just made this impossible. So to fix these two problems, we used OpenRefine. So now what we're going to do is fire up Google Refine and get into our data. So I'm going to create a project, choose a file. This is one of the files that we originally used. Okay, so OpenRefine, I can handle quite a lot of types of files, CSV, Excel, a whole lot of things. This is a CSV and it's comma separated. You can see this looks weird. This looks wrong. So I'm going to click comma and my preview should sort itself out. There we go. That looks a bit better. Okay, and I can immediately have a quick gander at my data before I create my project. It all looks fine. I'm going to click Create Project. And here it comes. Cool. So, some quick things to note. If we look around here, first of all, I can have different Google Refine projects, and this is the one I'm currently working on. I can rename this, which I probably should. Make it a little easier to find again. And it also tells me that I'm working with 113 rows, but if I scroll down, it looks like I've only got very few. And that's because Google or OpenRefine only shows a few rows at a time. You can show 5, 10, 25, or 50 rows. And that just makes it a lot quicker to use and to kind of scroll around in. You don't have too much data loaded in this section here. Okay, cool. So the next thing I do is just kind of have a quick look at my data, just get an overview. I've got location, data, I've got a whole lot of stuff I probably won't need, so I'll be taking that out. And I also see this top row is kind of empty, except occasionally there's weird data, like male, female, okay, under 25 years old. And also if I look at the titles of my columns, there's some weird stuff. There's this appears to be the time that each question was answered. So I'm going to be getting rid of those columns. And then you'll see the way this was formatted. We've got, so this is asking the sex of the respondent. So it came out as Q8 sex, column, and then male or female. So then the females all got stuck into this column, and the males got all stuck into that column. What we actually want is Q8 sex, male, female, male, female. So we need to fix that up. And as we go on, we see that same pattern coming over and over. So if I look at age, which had these options, under 25 years old, 26 to 40, over 40, and then that's been split into 3 columns again. And if it's on over 40, it's in this column. If it's 26 to 40, it's in this column. And if it's under 25 years old, it's in this column. So we're going to have to deal with all of that data and make it kind of normal. But the first thing we're going to do is get rid of some of these columns that we don't need. The quickest way to do that is just click on all, click on edit columns. It's a lot quicker than going through each one individually. So all these answered ats, I'm just going to take right out. These are the times that things were answered. I won't do them all, just give you an idea of what's going to happen. So, and we'll go as far as, oops, I need that. Let's go on back to that. Okay, I won't go through all the data and clean it all up because it does take quite a long time. I'll just do that. Just check, I don't really care where the latitude, longitude, or altitude, or location accuracy. Let's take that out. I don't really care what time they were surveyed, end date of the survey, or any of that information. Now I click OK, and it's going to take out those columns. So it's going to be a bit easier to work with. A lot of this kind of work is just really slog work. I'm just going to check a few of these text fields, just make sure things look okay. Quickest way is to just do a text facet on these. And I can immediately see I've got some weird stuff here. I've got a lot of different ways of writing the same thing. What I can do now is get Google Refine to help me a little bit. I'm going to click cluster over here, and what it's going to do is try and find similar phrases and let me kind of merge them into a single phrase. So this block X clinic will be merged. The Shoshanguve block X clinic, which is probably also block X clinic, so I'm just going to make that all the same. And then there's Q clinic, and then there's Port St. John's, which I'm just going to okay. And then there's a bunch of different algorithms that we can go through to see if we have any other outstanding things that it can find and help us with. I don't think it will solve all our problems though. Okay. So now we've got fewer of these things, but there's still a few. We can just quickly edit them here. Pretty quick to go do. And close that. You can always just go back a step, just by, or multiple steps, just by going to undo, redo, and clicking back a few spaces. So let me just see, what was it? Shoshanguve was block X clinic. Cool. Let's go back to where we were. It's going to become block. Okay. So it looks a bit better. We've got Port St. John's, Q Clinic, Tabong, etc., etc. Okay. Now we need to sort out those cells that we have multiple values, such as for sex and age, and we need to copy the proper values through to the original cells. So that's going to take a bit of a transform that we're going to have to write ourselves. Okay, so what we're going to do now is do a transform on this thing. So at the moment, value is literally the value of the current cell. But what we're going to say is, if the value is null, then let's get the thing next to it, which is column. So over here we've got q8.sex, and next to it is column. If q8.sex is blank, then let's go get whatever is in column. So this uses Google Refine Expression Language, which is a pretty simple language. We have an if, which is if true, then yes. So that's how if works. If true, then yes, else no. And it's always true. Change it to false. That's always false. Cool. So we're going to check. I think it is. So I have to cheat a lot. I have to go look this up. Non-blank. Is non-blank value. So is this guy a male? Yes, no, no, no. So I'm opening it. Could just say here male. Oops. We could do that and get our results. But what we're going to do is actually look up the value, because we're going to use this formula again and again. Else, we're going to get what's in cells. Cell name is column dot value. And there we go. And there, instead of a male female, we have the proper values. Now I can go along and delete this column if I want. Cool. So now I fixed male, female. This next one's a little harder. So, because now I've got two columns. This one's called Q9.age, this one's column 2 and column 3. So once I'm going to go to transform. I've got the same thing. The cool thing is this thing keeps a history of everything that I've used. So let's reuse this just to get us going. If it's non-blank, and value. Else, now we need to check if this one is non-blank. So now we're going to have to do a kind of nested thing. If put that on a new line so we can see what's going on. Else we'll go and get column 2. There we go. And we still need column 3. So let's do another line. There we go. Cool. So we kind of have to make it bigger and have a look. So we've got to kind of do cascading ifs, which isn't great, but there we go. And now, there we go. Our age is correct. Now we can get rid of column 2 and column 3. So now what we're going to do is take the data that we cleaned up earlier, and we're going to try and make some sense out of it. This is a spreadsheet that we've totally cleaned up and it's ready to go. I've imported it into Google Sheets, which will be fine for us to work in, but you can also use Excel or Numbers or whatever spreadsheet program you use in much the same way. Okay, so we'll just do a few simple pivot tables, which is basically what we did to create those posters. Okay, so let's take 6 as a real simple one. You just mark that column that I'm interested in. Go to data, and I'll go to pivot table. I'll add that 6 row as my row. And then I want to do is just find out how many people are male and how many people are female. So I'll add a field to my values, and this is trying to sum them up. I don't want that. I want to actually count them. Use count A, which basically means count strings as opposed to just count numbers. And I can immediately see I've got way more females than males, which is interesting. Cool. So that's pretty cool. That's a nice little table. Let's do another one. Let's get a little more interesting here. Let's look at sex and age together. Once again, make a pivot table. Now, because I had those two columns selected, it comes up with sex and age. I'll make one a row and one a column. Let's make age our row. Let's find it a bit easier to read. And make sex our column, male, female. And once again, we're going to add our values. We can choose either of these, it doesn't matter, because we're going to be using the number of times they have a value. There we go. Now we can actually start getting some interesting results. I can see there are very few people who are under 25 years old in the respondents, and they're all women. And then 26 to 40, and then over 40, there's a lot of people, still mostly women, because that's how much, you know, there were mostly women, but that, yeah. So the last thing we're going to do is just see if we can get any more information by doing a simple chart of this pivot table. So what I'm going to do is just mark this. I'm going to avoid the actual totals because that will mess up my chart. I just click Insert, Chart, and it gives me a couple options. Let's just go for a very simple bar graph, and there we go. Cool. So I can see that there's quite a discrepancy. The men tend to definitely be in the 26 to 40-year-old range, none in the under 25-year-old range, and very few in the over 40-year-old range. Cool. If you'd like to find out more about how we created this project, visit blacksashposters.codeforsa.org. Special thanks to Indigo Trust and the School of Data that made this project possible.